Question 11a. A particle is fired from the origin O with initial velocity 18 meters per second at an angle of 60 degrees to the horizontal. The equations of motion are d squared x dt squared equals 0 and d squared y dt squared equals negative 10. Part 1. Show that x equals 9t. It is given that the horizontal acceleration with respect to time, d squared x dt squared, or x dot dot, is equal to 0. Now the horizontal velocity with respect to time, x dot, is equal to the integral of the acceleration with respect to time plus the initial horizontal velocity. And that equals the integral of 0 dt plus 18 cos 60 degrees. And we can get 18 cos 60 degrees by resolving the initial velocity of 18 meters per second in the horizontal direction by drawing a right-angled triangle and using regular right-angled trigonometry. And the integral of 0 dt, of course, is 0, and 18 cos 60 degrees is equal to 9. Now the displacement x is equal to the integral of x dot, or the horizontal velocity with respect to time, plus the initial displacement. Now the initial displacement is 0, because we're starting at the origin. And the integral of 9 dt is just 9t. Therefore, x equals 9t as required. Part 2. Show that y equals 9 times the square root of 3t minus 5t squared. It is given that the vertical acceleration with respect to time, d squared y dt squared, or y dot dot, is equal to negative 10. Now the vertical velocity with respect to time is equal to the integral of the acceleration with respect to time plus the initial vertical velocity. And that equals the integral of negative 10 dt plus 18 times sine 60 degrees, which equals 9 root 3 minus 10t. Now the displacement of the particle in the vertical direction with respect to time is equal to the integral of the vertical velocity with respect to time plus the initial vertical displacement. Now the initial vertical displacement is 0 because the particle is starting from the origin. So y is equal to the integral of 9 root 3 minus 10t dt plus 0, which equals 9 root 3 times t minus 5t squared as required. Part 3. Hence find the Cartesian equation for the trajectory of the particle. The equations of the horizontal displacement of the particle x and the vertical displacement of the particle y are both expressed in terms of the time parameter t. From part 1, we have x is equal to 9t, and I'll call that equation number 1. And from part 2, we have y is equal to 9 root 3 times t minus 5t squared, and I've called that equation number 2. Express y in terms of x by eliminating the time parameter t. From equation number 1, t is equal to x over 9. And we get that by dividing both sides of equation number 1 by 9. From equation number 2, we're going to substitute x over 9 for t in both of these terms. So y is equal to 9 root 3 times x over 9 minus 5 times x over 9 squared. Expanding the brackets, we have y is equal to root 3 times x minus 5x squared over 81, which is the Cartesian equation of the trajectory.